our aim, uh, our primary primary purpose in electrical electrical system is to produce voltage, so that by having a voltage, we're able to cause current to flow, and as a result, we're able to produce the potential to do work, in the form of power, and eventually convert that potential into actual work. No? So those are the goals. No? So the goal is to initially provide voltage so that that voltage will create current, and the presence of current and voltage result to power. And once you have the potential or the power, potential to produce energy, then you can now produce energy or heat. No? So that's our ultimate uh, output. But amidst all of those, natay kontrabida, no? Natay opposition. And that is the resistance if you're talking about DC. In alternating, there are more than this, more than resistance. No? So natay reactance, natay capacitance, or inductive reactance, capacitive reactance. These are all the oppositions. No? These are all the anti-current. So why is it important for us to identify the resistance? No? So why is it important for us? Anong kinanglan mo mag-identify sa resistance? In fact, there are a lot of studies, no, in research, and a lot of study is involved, no, involving resistance. So muna dako nung kay sa emphasis, no, dako nung kay emphasis ang resistance, which is kontra sa ato ang goal, which is to produce output in the form of heat or work, diba? So sa may ato ang reason, why do we have to waste our time, a lot of precious time, studying resistance, when in fact we know that this in electrical system, this is more of disadvantage rather than advantage. So that is because sa gira pa na, you cannot go to war without knowing your enemy. Diba? You cannot just say, mag sa wire. Diba? So, panagal akong 12 volts sa akong wire. Wala nimo kwintaha kung pila yung resistance sa wire. In such a way nga, tungod ka na ko sa resistance sa wire, pag abot ito sa imo ang load end, ang voltahe gamay na kayo. No? So instead nga require ka og 12 volts, pag abot sa load end nimo 9 volts na lang. So dili na enough to run the load, which requires 12 volts. So that is why it is important for us to know kung unsay ato ang opposition, how much the opposition, so that you'll be able to adjust. No? That explains why ang ato ang load is supposed to be 220, but if you look at transformers, tanaw mo ng transformer dapit sa kasada kanang nasa poste kanang lingin, ang makita ni mo di ang marking nila is 240 volts. So naay siya ay 20 volts na extension sa nominal voltage. Actually, ang nominal voltage ato is 230, kanang 210 is the lower extreme, kanang 240 is the higher extreme. So the nominal, the proper voltage 230 volts. So nganong naman tay extension na 10 volts or kanang 20 is okay pa man, to 20 is okay pa man. Ngano naman tay 20 volts nga extension sa rating sa transformer. So muna sa papa nga istorya, kung gikan sa Naga padong sa CIT ang pliti 20, okay? So dili tingali ka mangayog balik 20 rasad. So imo ginapakapinan, no? Nagi ka allowance. No? So mora gyapon na sa ato ang transformer. Kanang 20 volts nga extra na volts niya is actually the extension or the extra volts, so that kung abot ka sa imong load end, kung na kay voltage drop, it is within the gyapon the standard voltage or the allowable voltage. Okay? Aside from that, power loss is also computed having the values of the resistance. If you don't have the resistance, then that would be difficult for you to identify the power loss in the system. So actually kanang power loss atong system na kita og heat loss, or that's the power loss due to heat produced in our system. So what are the sources of these resistances in the materials? No? So unsa may cause or asa man gikan, no? Where does this resistance came from? So number one, siya, no? Inert, meaning inherent sa imong kable nga nagi sa resistance, or inherent sa material nga nagi sa resistance. No? So that's the resistivity of the material. In fact, that's the reason why when you talk about kanang sa safety, dili sila mo emphasize gyud og person to person nga standard yun nga resistance, no? So for example, one person may have different body structure. So kung lahi ang iyang body structure, lahi siya og internal resistance compared to another person. Pareha sa mga tao, pero lain-lain ta og body structure. Since lain-lain tag body structure, tendencies lain-lain ta og resistance. Muna nga naay mga binuang wagay ko makurintihi, no? So hika mag-wire, mingon day wagay ko makurintihi, ikaw pa. So ayog tuo ana, no? Because lain-lain ta og body structure, meaning lain-lain ta og resistance sa body. So the amount of current that will flow in the body, no, will vary depending on unsay condition nimo. For example, let me give you an example. Katong mga bulky, mga muscular people, no, are actually, no, kung imo nang tanawon based on our formula later on, bigger people should have a lower resistance, should have the same current. Pero normally, kung mga dagko kayo, mingon nga, uy, nakurintihan, dakong tawo, wala gyud siya maunsa, wala gyud siya ka-feel kayo sa kurinti. Actually, dako ang kurinti, but most probably it's because kanto siya nga dako nga tao, dito siya sensitive sa pain. Muna yun siya wasa makurintihi, di siya sensitive sa pain. No? So, dako kay nga aspect kung yung ka nga magkuha ka og resistance sa body, lain jud siya, no? So, in the materials, different type of materials have different resistivity. That is why natay gitawag nga mga materials nga conductor, naputay gitawag og insulator. So when you say conductor, these are materials that allow current. Insulators, these are material that doesn't allow, no? Actually, kanang term nga doesn't, no? Subject na siya, no? Subject. So subject to how much voltage there is. There is no such thing as absolute insulator, ha? Kay kung buot nimong hunaon kani ato ang hangin, no? Air is a natural insulator, di ba? So kanang hangin natural insulator na siya. But during thunderstorms, kanang makita na itong gabadlis sa sky during thunderstorms, those are electrons, those are electricity. Electricity na siya, no? Kanang makita ng mga kilat diya, mga gabadlis, electricity na, electrons na siya, traveling from one cloud to another cloud or from the cloud to ground. Actually, duha na siya ka klase ang cloud na ato ang strike, no? Excuse wala man akong
Excuse me, sir. Pwede ma-record ang discussion, sir. Thank you, sir.
Okay. Sa record. More record. Okay. So, again, next time, reminds ako kay makalimot ko, no? Okay. So, as what I have said, kanang streak, no, colored streak that we see from cloud to ground, no, actually duha na siya ka kuha, no. So you have the padong sa ubos o naputay gikan sa ubos padong sa ground, padong sa babaw, no. Muna ato ang gitawag og kaning upward o downward nga stroke. So muna ang lightning is not actually from the sky padung sa ground lang yun siya, kung dili na siya ka meet aning niya ang kuan upward stroke, no, muna ito ground leader, kung dili na sila mag-abot, then there is no lightning strike padung sa ground. That explains why sometimes you hear the thunderstorm but you don't see a strike going towards the ground, no. In electrical system, kanang atong mga lightning arresters, no, kanang makita nato nga naay tower, naay mga tower, then at the tip of the tower, no, like in CIT, you will see a spare, na spare sa babaw, no. Kani siya nga spare is actually the one that is going to produce an upward strike, no, kanang iya ang upward leader. So ang purpose ani niya is when naay ionization paduol sa surrounding. For example, na kay building diri, no? This is sitting on top of the building. So if this is sitting on the top of the building, ang ang zone of coverage, ang yang i-cover nga safety ani niya, i-protect niya ang imo ang building from this lightning strike within this zone. So ang purpose niya is kung ionize ang imo ang cloud or some ang surrounding niya, before the lightning strikes can strike, no, any part of the building, yan ang i-attract by producing an upward stroke. So kaning imo ang spare diri mo produce sa upward stroke so that magkita sila sa imo ang downward nga stroke, no. So the purpose of which is muna sila dakpon, no? That is why ang term is lightning arrestor. The lightning arrestor arrest lightning instead of hitting neighboring structure. It will go to the spare going towards the tower. Then this tower is connected to the ground, no? Connected to the ground. So kung unsay current ma-generate makuha niya adto na ibutang diri sa ground, no? So if you have passed by kuan or kung nakabantay mo atbang sa accounting, no, atbang sa ATO na poste de na haligi diha nga dako facing the kanang garden na ay kuan diha, no, na ay wire diha nasa sud padong sa ground. In fact, sa ubos diri na gibutang niya og lightning counter, mag-count sa kung pila naka-strikes ang nego aning lightning arrestor. Okay, so we have that in CIT. So the purpose of which is if na lightning strikes within CIT, as long as masud sa zone niya, sa zone of protection kaning spare, it will not just hit anybody else. So actually kung nakada sa main building sa CIT, basta pag magkilat ya ayaw kahadlok, no, di kita mahadlok. Pero if you are staying in the architecture building or in the elementary or in the canteen, kana kuyaw-kuyaw na siya kay layo na kayo na siya, no, o di na maabot sa iyang zone of protection. Okay, so the resistance is also dependent on the length of the material. So meaning the longer, no, the higher the length. No? So for example, if you're going to compare the two, no, compare this and this conductor will have a lower resistance compared to this, no? Because the longer the wire, the higher the resistance. Also, cross-sectional area also affects the resistance. The bigger the wire, the bigger the smaller the resistance. Okay. Then the fourth parameter is the temperature of the material. So this is also a very important aspect, no, in electrical system, identification of the temperature in the material. So this has smaller length, larger area, so that the result is higher resistance. Kani is larger length, smaller area, and the result is greater resistance. Okay? So, as long as the purpose of which is to allow or to let current flow from A to B, no, from point A to point B, no, then as much as possible, the current that's going to flow from A to B should be unhampered, no, should have a lower resistance as much as possible. But if the purpose of which is to produce heat, no, if the purpose of this activity is to produce heat, then you would also desire a greater R compared to the lower R, no? So mas maayo kung dakong R kaya haron mo produce dako nga heat. Okay? So these are some of the resistances or resistivities. Okay. So resistance, as what I have said last time, that resistance is directly proportional to the length and inversely proportional to the cross-sectional area. So to remove the proportionality symbol, no, we have introduced, or another parameter is introduced, which is the rho, the resistivity. That is the constant. Meaning, for every material, nakagusay usara ka rho. For example, let us say silver. Silver has a resistivity equal to 1.59 times 10 to the negative 8 ohm meter, no? At 20 degrees Celsius, which is higher than copper. Okay? So kung tanawin mo, higher than copper, no? Which is 1.68. And followed by annealed copper, then we have gold, then we have aluminum. But why are we using copper instead of silver in our conductor? Why are we using aluminum instead of copper, instead of silver? Though, kung tanawin mo, if you choose among these materials, pinaka-best niya na kuan is ang silver, good, no? So second best ra ang copper, dayon layo na gid unta ang aluminum. Okay? So this has a lot to do with the cost, no? Silver is much higher in terms of cost compared to copper, and it's more rare than copper, no? In fact, nowadays mas gi-introduce na ang aluminum, daghan ang ga-introduce aluminum or gina-market nagmayo ang aluminum. It is because of the reduction or the dwindling available copper, no? So nagkagamay ang ato ang copper, so that nagkamahal, nagkagamay. So ang ato ang mga material developer diverted to aluminum. On the other column, most of niyang yang opposite, no? If this is the resistivity, this is the property of the material that tend to oppose flow of electrons or electricity. On the other hand, muna ang kani, kuha siya, no? Tawag ito ni, muna siyang opposition. Kani ang amount or property of the material that tend to allow, no? How much would it allows flow of electrons or electricity. So ang conductivity sa silver is higher than that of copper and aluminum. But again, ang atong gigamit nga material is copper and aluminum. We're not using gold, no? So if you look at gold is higher or better than aluminum, but we don't use gold, no? Kanang katong mga spare nato sa lightning arresters, they are coated with gold, no? So silver, gold. Okay. So Aside from these materials, napatay lain, no? So napatay tungsten. Tungsten is can also allow current. The advantage of tungsten, that is why tungsten is used in our filaments, is that it doesn't easily burn. No? So mas taas siya tolerance sa heat compared to copper and aluminum because eventually malanay man sila kani mas taas siya tolerance to heat. Nga mabagal lang siya. That is why this is being used as filament in our incandescent lamps. No? So we have other materials and so on. No? So stainless steel. Then we have carbon, so on. Rubber. No? So tag-as na kayo sila, tag-as na kayo resistivity. Mga to ang mga kuan. Naog up to Teflon. Okay? So these are some raw materials. So air, look at air. Air ranges from 1.3 times 10 to the 16 ohms ohm meter to 3.3 ohm meter, no? So muna ang range of resistivity sa air, no? So again, that is why I have mentioned ganina kanang term insulator, that's actually subjective, no? Subject to how much pressure applied. For example, you might have already touched a battery that's rated 24 volts and you didn't feel anything, but that doesn't mean nga may ka nga kuryente king nako, no? Di na ko madutlan og kuryente kay gikumot ako tong gigunitan ako tong positive negative sa battery sa sakyanan, wa man ko kuryente na makita nimo nag-spark siya, so meaning imong iko nagbaterya ikuat sa material or sa wire mo spark siya, so meaning nagay voltahe. And yet imong gigunitan wala ka ka-feel of current. In fact sa EE, this was the practice before, but when I came in as chairman, I discouraged na, no? Sa una ang ilang sa mga na-subject sa EE nga maglinya sila, palinyahon, then mag-live wire, no? Tapping. So i-tap nila ang wire, buhi, no? But they are stepping on a rubber matting. So magtunog sila sa rubber matting, dayon ilang i-splice, i-connect ang duha ka wire na voltahe. So miyo to, sir, dili makurintihan. Actually, wala pa gyud pud nooy na kurintihan, simbako lang pod. That is because ang imo ang resistance padung sa ground, ang agyanan sa kuryente perti ng dako sa opposition, no? Because gagamit man tag rubber, gapatong ng rubber. Pero malagi na nga, as Sam said, do not wait for accidents. Kaya wata kay balo nga katudeng rubber o kakabantay o sa condition to na-degrade na to, na-deteriorate ito yung resistivity, no? So kanang term nga resistivity subject to how much voltage applied. So kung yung ka nga 24 volts, waka makuryente, don't apply that same logic sa 240 because that's higher voltage na. So magkadako ang imo ang voltahe, kanang imo ang insulator becomes a lesser of an insulator, no? So may ka nga rubber sa imo ang tools. So ang rubber sa imo ang tools will have a range of voltage nga pwede magamit nimo. Magkadako ang voltahe, di na to siya pwede gamiton nimo. You are to upgrade sad to electrical tools with taas nga voltage ang yang range, or as what others have been doing. So malagi na nga mupatong sila ang TL, ipatong og kanang rubber. Then one thing nga makatabang class is kanang imo ang feet. As much as possible, your feet should be very close. Muna itong itawag step potential to minimize the step potential. Okay? So if you're so as much as possible, no, kani imo ang tiil kana ang distance ani nila should be very close so that wala kay dako nga potential between one leg or 1 feet to another feet. Muna to gitawag og step potential. No? Step potential. Nya ay mo kabalaka mi mo katawan niya mo nga kuha no. For example, if you are in a surface nga yung ka na grounded, na poste, na wire nga natagak diha, nya naka sa duol, no, naka sa duol. Nya ang wire ga spark, no. Bahala na sila katawan kanila. Pero ang imo ang buhaton diha is to hop like a bunny. No, kada ba magutol-untol ka nga imo ang feet dili mo ibuwag. Hop up to kung asa ka dapit pinakalayo na dayon kaayo diha, no? Kay the shorter the distance from the point of naa diha ang grounding nimo, magkamubo ang distance nimo, no, ang length man na. So magkamubo ang length, magkagamay ang resistance. So your goal here is to move as far away as possible so that ang total length nimo from the point where naa dito ang wire na putol padong sa distance nga imo ang final end nimo, ang length nimo taas kayo. So kung taas kay ang imo ang length, then you'll have a bigger resistance. And again, the manner with which ayog daga, no, the manner with which you are going to move from this point padong dili sa farthest point is as much as possible moving or walking with your both feet closer enough. So muna to gitawag og hop, no. So the purpose of which is dili nimo dakog distansya kay kung muna mo ang left, muna mo right and left, ang imo ang step potential, the potential between this and this is taas. So kung naay dako nga potential nila, difference between one foot to another foot, dako ang potential, then there is a tendency nga current will flow. Mudagan ang kuryente padong sa lawas, mo padong sa pikas end. So kung distance nimo duol kayo, wala may potential difference between one foot to another foot, so wala current mo circulate sa imong body. Muna nga kung nakabantay mo na muhap, no, mag-ambak-ambak. So mingon sila ana, yabag na nito ana. Ay ina, mas bahala yabag basta buhi. Di ba? So bahala yabag basta buhi. Ang kana pinaka-importante diya is kanang safety nimo. So again, has something to do with the resistance. If that is the case, your goal here is to establish, no, a very high resistance. So makakuha ka dapat og dako kay nga resistance nimo from the point, the source of current, the voltage, no, padong sa imo ang end. So dapat dako kay nga resistance nimo para magamay ang kuryente. Okay. So natin duha ka ano, the touch and the step potential. So mo po na sa touch, no? And that explains why birds that are perching, no, kanang bitong langgam nga gabatog sa linya sa babaw sa kuan, kanang mobatog sa atong linya sa kuryente, di na mo kuryentihan, ha. Wata kitag langgam nga nakuryentihan. Kay kanang imo ang langgam magbatog na siya, dili mo siya mo split, no. Di makakitag langgam nga kani ang wire, ang pikas tail na diri, ang pikas tail niya diya, no, mi split. Magbatog ng langgam, dikit na lang yung tail. So wala ay potential. So meaning with respect to the bird, no, ang kuryente dili siya makakita og potential between both legs. So dili ka generate og current padong o dili ka kuan og current padong sa body sa bird. So that ang bird with respect to the electrical system, mura na siya ganang floating, no? Floating. So wala kuryente moagi sa iya. Therefore, di mo kuryentihan ang langgam. Muna kung patong ka og, no, linya sa beko, imo gidikit mo. Ayaw lang, no? Kaya umantahan, hindi mo kita pwede mo pan. Allowed. That's not safe. So, example, you have a coil consists of 200 turns of copper wire having a cross-sectional area of 0.8 mm squared. So, the mean length per turn is 80 cm and the resistivity of copper is 0.02 micro-ohm meter. Calculate the resistance, no? So, calculate the resistance and power absorbed by the coil if connected na siya, no? If connected to 110 volts DC. Okay? So,